Hello, this is your week 6 promised help video. I want to talk a little bit about confidence intervals as we begin here. So basically the big idea, let's start there. The big idea is you have a population. You're really curious about the mean of that population. What is the mean of that population? Excuse me. But we don't have the resources to find out all the data of every single person in that population. So we take a random sample and we find the sample mean. The sample mean is the best estimate we have for the population mean. However, it's just 1 point, so we call it a point estimate. Sometimes we want to be a little bit like, give ourselves like a range. Like we want to know not just what that 1 point is, but what is a good, reasonable range that we believe the true mean to be within. And so we construct a confidence interval. A confidence interval is always a point estimate plus or minus a margin of error. So we construct that based on what we know about the population. So let's take a look at this first question right here, and let's go over that. It says, you measure a 22 randomly selected textbook weights and find that the mean weight of the textbook. So this right here is your point estimate, 36 ounces. And we also know that we took a sample of 22. And of that, they tell us a population standard deviation of 5.5. Now, the reason this population is important, like this word population is so important, is because if you know the population standard deviation, then you can base this confidence interval on a regular normal curve, which we call a z-interval. But you only get to use a z-interval if you know the population standard deviation. If you don't know the population standard deviation, then you're going to use what we call a t-interval, which uses a different distribution that is also bell-shaped but has slightly heavier tails. So we're going to use a z-interval because we have the population standard deviation, and we know that that standard deviation is 5.5. Right? I'm going to build this first confidence interval by hand for you. The other thing that we need to know is that we want this to be a 90%, right here, a 90% confidence interval. So we want it to be a 90% confidence interval. So, all right, so if we're looking at 90% here, I'm looking for the numbers here that give me 90% in the middle of a normal curve. These numbers down here on this cutoff are called critical values. They are called critical values, and they give 90% here and here. Right? I can find those cutoffs by going, I'm given a percent, I'm looking for a cutoff. If there's 90% here, that means there's 5% out here and 5% out here. So for me to get up to this top cutoff value right there, I would go inverse normal on my calculator or on Minitab, and I would type in that I'm like 95% of the error in a standard normal curve, so mean of 0 and a standard deviation of 1. So when I do that on my calculator, I end up with 1.64485, which I'll just reduce to 1.64. Now, you'll notice this one right here, this is completely symmetrical, so this one would be 1.64 as well. So now this is called my critical value. It's a number that comes from the shape of the distribution that tells us how many standard deviations away from the mean I need to go, this cutoff right here, to get the range that I want, the precision that I want in my confidence interval. So now I'm going to do this whole thing like by hand, not doing any super shortcuts. I'm going to take 36 plus or minus my critical value times my standard deviation divided by the square root of n. Right? This part right here is the margin of error, and it is 1.9289. So I am going to subtract that from 36, and I'll get my lower limit. And add it to 36, and I get my upper limit. Okay. So that is how I do these problems. There are some significant shortcuts to do these problems, and I'll do question number 2 using a shortcut. Work on my second problem. You measure 25 watermelons weights and find they have a mean average of 47 ounces. Assume the population standard deviation, so again we're doing a z-interval here, is 10 ounces. Based on this, construct a 95% confidence interval for the 2 population mean of watermelon weight. So again, this is problem number 2 of the homework. So I'm going to be in my home screen. So go to my home screen. Here I am. And I'm going to hit Stat and over to Tests. I'm on a TI 83, 84, and I go down to number 7, which is Z interval, and I hit Enter. And then it asked me, do you have a list of data or do you have summarized statistics? They gave me statistics. They told me that my population standard deviation was 10 ounces. They told me that my mean was 47 ounces. They told me that my sample size was 25 watermelons, and they told me that my confidence level was a 95%, and they asked me to calculate, so I hit Enter, and here I have my confidence interval is given in these parentheses from 43 to 50 values. I'm going to take a quick screenshot of that. Okay, now, so we had that screenshot, or we have the screenshot here, that tells me that my confidence interval is between 43.08 and 50.92. But that's not actually, it's not asking, notice the difference between this problem and this problem right here. It's actually not asking what the interval endpoints are. It's asking for the point value, which we know was 47, plus or minus the margin of error. So to find the margin of error, we need to know what the difference, if I subtract 47 from here, then I would have 3.92. And if you'll notice that if I were to take 47 minus 3.92 on my calculator, 47 minus 3.92, I get that 43.08. So what we want is this is 47 plus or minus 3.92. So that's the answer they're looking here. That can be tricky. You have to really look at what format they want the answer in. Do they want it as a point estimate plus or minus the margin of error, or do they want the 2 endpoints in an interval notation? I'm going to stop here and post this video. Otherwise, it might be too long to post on the internet. So, because we're approaching 10 minutes right now. So this is problem 1 or 2. A lot of you might just be able to watch problem 1 or 2 and feel like, okay, I have a pretty good understanding. But I will come back through and find out, do some more problems so that you have a better understanding as well.